Right, we have a triangle with some squares drawn in it, and we're asked to find the area of the whole triangle. So I already know some areas, so if I can work out the area of all the triangles, I can add them all together to get the area of the bigger triangle. I have the area of the square is 10, which means I can work out the base of the side. So this is going to be root 10. This length is going to be root 90, which is root 9 times root 10, which is 3 root 10. And here I have root 40, which is root 4 root 10, or 2 root 10. And knowing that, I'm not going to write every single length on this. So obviously the height is also 3 root 10 here, and this is 2 root 10. I'm going to focus on this triangle here. Because the height of this triangle is going to be, because the height of this square is 3 root 10, I'm then going to minus the height of this square, root 10. The height of this triangle is going to be 2 root 10. And the base is going to be root 10. So I'm going to add that on. Now let me call this angle x. Then this is 90 degrees because I've got squares next to each other. This angle is going to be 90 minus x. And then this angle, because this is 90 degrees, is going to be 90 minus x. And then this is going to be x, because this is 90. And actually, these two triangles are similar because they have the same angles, so I can use some of the properties of them. And one property I can immediately use actually is because I see the height is root 10, and I see this height is double the base, it must be that the base of this triangle is going to be root 10 over 2. Okay, that may or may not be useful, but I've calculated that length as well. And actually, what it allows me to do, I'm going to focus just on the green triangle for a minute. I'm going to try and find all the different lengths. So this is 2 root 10, and this is root 10. Then I can use Pythagoras' theorem to work out the longest side. It's going to be root 10 squared plus 2 root 10 squared, which is the same as root 40 squared, square rooted, so I get root 50, which I'm going to write as root 5 times root 10. I'm going to keep everything in terms of root 10. And one reason for that is that there are root 10s in the answer. Second reason is, I don't know, it just seems to be like when I'm adding, I might be adding them up in a minute, that'll be useful. So let me work. I'll continue to do lengths in red, I think. This here is going to be root 5 root 10. And what I see is basically the shorter length, I just times it by root 5 to get the hypotenuse. So for this one over here, it's going to be root 5 root 10 over 2. Okay, I think I'm now going to take a little look at this triangle. Yeah, it could be very tempting at this point to say, hey, they're all going to be similar. And you would be right, and you'd get away with it, and you can solve this problem more quickly. But we need to, technically we need to show it, so I'm going to show it. All right, in this triangle, I've got 2 root 10 here, and then now it's the height of this blue triangle because it's in a different orientation. It's going to be 3 root 10 minus 2 root 10. So this is going to be root 10 as well. And that would show that actually the blue and the green, they are congruent triangles, but actually all of them are going to be similar. Like this is going to then be x. This is going to be 90 minus x. That's going to be x. 90 minus x. So I can start using some ideas that we've found. So I know that the smaller length of this bigger triangle on the bottom right, that is 2 root 10 in height. So if I double it, this is going to be 4 root 10. And I'm also going to get the hypotenuse, because remember I took the smaller side and then I times it by root 5. So it's going to be 2 root 5 root 10. And then this one, just like for that green triangle, that is going to be root 5 root 10. Okay, there's just one triangle I've not looked at yet. It's actually in a different orientation to all of them, so let's need to be careful with this. Well, I have that is x, and that is 90 minus x, which means I've got a right angle here. And that I can see now my way of finding the area, because if I can work out the whole of this length and times it by the whole of this length and divide by 2, that'll give me the area of the triangle. So let's just think about this. Um, I could, and actually they do in the answers, split it into a triangle like this, and they look at this and this, but these lengths seem awkward. So actually, I'm not going to do that because we have a useful length already, and it's this one here. I know that this length is 3 root 10, and that is my hypotenuse. So to get from the shorter lengths to the hypotenuse, originally I was timesing by root 5, which means that to get from the longer length, the hypotenuse to the shorter length, I need to divide by root 5. This is going to be 3 root 2, and I know I've broken the rule. Before we had root 10, root 2, and 10 everywhere. Okay, but that's what it is. I'm going to have to roll with that. That one's 3 root 2. And then if I double it, then this is going to be 6 root 2. Oh, that was a lot of hard work, but we're nearly there. And so the base, now when I say the base, I'm going to talk about this length here, okay? I don't know whether to add it on, yeah. Let me call it, right, this one is the base, B. And it's going to be root 5 root 10 over 2 plus root 5 root 10 plus 3 root 2. Now, actually, this isn't as bad as it might have first looked when adding these surds, because I'm going to get root 5 root 5 root 2 when I separate that root 10 up over 2 plus root 5 root 5 root 2 plus 3 root 2, which is going to give me 5 root 2 over 2 plus 5 root 2 plus 3 root 2. If I put it all over a common denominator, it's going to be 5 root 2 over 2 plus this is going to be 8 root 2, so it's going to become 16 root 2 over 2. Oh, and I'm going to get 21 root 2 over 2 as the base. Okay, good. And now my height is going to be this one here for me, okay, because there's the right angle. So I'll call it H. Now I need to add these up. So I've got 6 root 2 plus root 5 root 10 plus 2 root 5 root 10. But in a similar way, this simplifies nicely. I'm going to get 5 root 2 here, and I'm going to get, sorry, was that right? Yeah, that was right. 10 root 2 here. And it's going to become 21 root 2. So the area, finally, is going to be a half base times height, half times 21 root 2 over 2 times 21 root 2. The root 2's are going to become 2 and cancel with that one. So actually all the thirds are gone, and I've got 21 times 21, which is 441 over 2, and that's going to give me 220.5. Nice one.